number system. Okay, so there's, because you have to already, you know already, because this is the octal very basic part, and in class 12 standard, maybe class 8, 9, but few concepts is required. Okay, so directly I am going to the octal number system, a compact way to represent binary numbers. That means when we are directly going to the only binary number system, that time what happens, when we are representing some particular numbers, that time what happens, sequence is very large. Sequence means what? Combination of 0 and 1. But when we are talking about the octal number, that time what happens, we are compactly representing. That means what? See here, always remember, when we are talking about the octal number, that time what happens, group of 3 binary digits are represented by octal digit. Okay, any octal digit, when we are converting to the in the form of 0 and 1, in the form of, that means sequence of binary form, that time what happen, we are representing only 3 binary digits. Okay, so what happen, see here, 3, why we are using 3, because what happen, see in this particular table, we are going from 0 to 7. Okay, we are starting because minimum value is 0 and maximum, again someone is joining, sorry for this one, just a minute. Raj Buffer, you are the class representative, please timely join. Okay, because don't getting late. Okay.
Okay, sir.
PPT is visible, na? PPT
Yes,
is visible. Okay.
Yes, sir.
So what happens? See here. So we are representing the range of the octal digits are 0 to 7. Why it is 0 to 7? Because minimum value is 0 and maximum value is 7. But when we are, again someone is joining a Ayush Kumar, are you hearing me?
Yes, sir. I can hear you. Good morning.
So why you are attending this particular subject? Because you have a backlog or what?
I have a backlog in this subject, sir.
Okay, then when your exam will be conducted? That means next semester or this semester, or you can give the supplementary exam? Oh,
no,
supplementary.
Yes, I'll have to take it this semester only.
Okay, very good, very good. So you can maintain your own regular semester. Okay, that's if it is class or it conflict, then sometimes I am taking the remedial class or extra class. I will manage. But if you have a time, then very good. If you have a time, then you will join. No problem.
Okay, sir. Okay.
So see here. So total is what? Minimum is 0 and maximum is 7. So what happens when we are representing? That means what? 2 to the power 3. Because when we are talking about the every numbering system, there have some particular base, or you can say radix. Okay. So when we are talking about the binary number base is 2, and when we are talking about the decimal number base is there. But similar case, when we are talking about octal number, the radix is 8. Now what happens? Maximum, what is the difference between this particular course? That means earlier what happened, you are learning what is octal number, what is you have in class 10 or 8 or something like that. But you don't know why we are using 8, why octal number radix is 8, but why binary number radix is 2. Okay, why decimal number radix is 10. So some type of conceptual, some type of basic concept, that means we are going to discuss. So octal number means what? We are representing maximum total number is 0 to 7. Then how many, what is the cardinality? Cardinality is 8. That means size of that particular range is 8. So what happened? How we can representing in the binary form 2 to the power 3. So 3 means what? 3 bits are required. I'm very much sorry because again someone is joining. Alimuddin. Okay. Alimuddin. Alimuddin. Are you hearing me?
Here.
So why you are getting late? It is up to 9:14.
Oh, sir, I was sorry, sir.
Okay, in next class you can maintain the time, huh? You can maintain the time. Otherwise, when I am providing the full screen of PPT, that time again I am going to that particular window, so it is time consuming. Okay. So what happened? See here. So every octal number we are representing 3 bits. 00 representing 0001, 1 representing 001, 3 representing 011, 7 representing 111. Again. Aditya, Arnab, Pike. I'm telling you, see here, if after 9:10, suppose my class is started around 9 a.m. and interested to join after 9:10, that time what happened? I am not allow you, because this particular announcement, this particular problem I will not announce earlier. So for this particular class, it is okay. But after 9:10, if someone interested to join, then I am not admitted. I'm not allowing you. Okay. So before 9:10, it is okay, and up to 9:10, it is okay. After 9:10, I'm not allowing you. Okay. See here, now what happened? How we are converting binary to octal conversion. Okay, you have obviously you have binary to decimal or decimal to binary. You have already know. So how binary to octal conversion is required? Okay, so I have already discussed any particular numbering system. There are two parts. One is called an integer part. One is called a fractional part. Fractional part means what? Whatever the numbers are coming after decimal point, that is called a fractional part. So this is the nature of the numbering system. Okay, you cannot ignore this one. So this one is called an integer part, one is fractional part. But what happened? Any conversion of numbering system, the rule is something different for integer parts as well as the fractional part. So similar concept we are using in the octal numbers also. When we are talking about the binary integer part, and remember this particular case are coming when we are converting binary to octal conversion. That time what happened? Scan the binary numbers from right to left. Remember, when we are talking about the integer part, that time what happened? We are scanning the binary numbers from right to left, not a left to right. And after that what happened? Translate each group of 3 bits into the corresponding octal digit. So what happened? Each group means what? Each group of what? 3 bits. Because you know, when we are representing the octal number, that time what happened? 3 bits required. That means combination of 3 bits are required. Okay. And when we are converting this one, that time what happened? At leading MSB zeros if necessary. If when we are sometimes what happen, we are not we are unable to construct the 3 bits. That time what happen? We are adding zeros in the MSB side. Now what happened? MSB means what? Most significant bits. That means when we are writing any binary numbers, the leftmost side is called a MSB. Okay, and the rightmost side is called a LSB, least significant bit. That is the rule for integer part. But when we are talking about the fractional part, see here something is different. Scan the binary numbers from left to right. Now, again what happened? Translate each group of 3 bits into the corresponding octal digits. And when we are unable to construct sequence of 3 bits, that time what happened? Add trailing. Trailing means what? Least significant bits. It is required. That time what happened? We are adding 0. But remember, not 1, only 0. Now what happened? You are asking me why we are adding zeros MSB in the integer for the integer part. Why we are adding zeros in LSB for fractional part? Can you tell me why? Why we are MSB and LSB, the concept is coming? Anyone? Anyone? Are you hearing me now? Hello, are you hearing me?
Yes, sir.
Yes, sir. Yes, sir.
Are kuch to boliye nahi to otherwise how I can understand? I'm afraid that means network is gone or something. Please reply response. Okay. Are you getting or not? MSB means what? MSB means what? When we are writing, suppose see here example. Yes, most leftmost bit. Okay, most that is, but don't use the leftmost word because this particular word is not allowed in digital electronics. So we are using most significant bit. Suppose see here example, the first one, point number one, 101.101.00.000.000. Can you see here the left most the left side most significant bit is one. So in left side, the first bit one is called a most significant bit, and the right side also appears one that is called a LSB, or you can say trailing or leading. It is common word, common keyword. But here we are using two terms in digital electronics: MSB and LSB. Okay. See here, when we are talking about the integer part, then suppose I'm not going to the binary numbers, I'm going to the decimal numbers. It is easy for you. Suppose for integer parts, I'm using 25, and fractional part, I'm using 35. That means how we can represent this one, 25.35. If I'm using before 25, if I'm using 0, and after in fractional part, after 35, I'm using 0. There is any meaning? Equal to what? 0.25? No. So that means what? But remember one thing, that if we are using 0 in the fractional part in MSB, that time what happened? The meaning is the value is something different. So it is this particular procedure actually follow based on the mathematics in nature. Okay. So for that particular reason, we are using MSB and LSB. Always remember, integer part we are adding zeros in MSB, and for fractional part we are adding zeros in LSB. Now see here some particular, this is very conceptual. Not even suppose for examples, see here we are using some particular binary numbers, and see here I'm underlining every 3 bits. Okay. So what when we are talking about the integer parts, we are going from right to left. Remember, we are not counting from left to right. Because see here now now you feel that yes, this was very easy, we can do it. But what happen when we are followed some particular procedure or systematic way, that time what happen, you're always you are correct. Okay. But some many students or they are not following this particular right to left or left to right. So that time what happens, some particular problems are coming. And in this case, what happen, if some particular bits may be changed 0 to 1, that time what happen, your answer is wrong. So it is depend on very careful. So what happen, we are going very systematic manner. Okay. So what happen, see here, the example number 1. So this is totally integer. There are no points is there. So that time what happen, according to the integer part, scan the binary numbers from right to left. So right to left, what is the right? If we are going the right, that time what happen, first 3 bits are occurred 0, 1, 1, not a 1, 0, 1. 0, 1, 1, after that 0, after that 1, 0, 1, after that 1, 0, 1. In this first example, there is a no problem because all are constituted with a 3 bits. Okay, that means sequence of 3 bits. So 101 is this what? It is representing 5. Okay, 101 again it is 5. 000 again it is 0, and 011 again it is 3. So you know how to represent binary numbers to decimal. So that's the same formula we are using. So 101 means what? 2 to the power 0 into 1, 2 to the power 0 into 0, and 2 to the power square into, or 2 to the power 2 into 1. Okay. So if we are using 2 to the power 2 into 1, 101 means it is representing 5. 101 it is representing 5. 000 it is representing 0, and 011 it is representing 3. Now what happens? See the next example. We are going from, again we are going from what? This is the integer part. Again we are going from right to left. So at first it is coming 011. Yes, it is 3 bits sequence. It is okay. 001 it is 3 bits. 010 it is 3 bits, but 1 is not a 3 bits. Only 1 bit is here. So we are adding 0 in MSB. Zeros if necessary. Okay. So when we are adding zeros, that time what happen? It is going to 001. So 001 it is representing 1, 010 it is representing 2, 100 it is representing 4, and 110 it is representing 6. So I am writing 2 leading zeros are added. So here I am not showing, but you remember you can use the 2 leading zeros are added. Okay. So next, see here, example 3. Here what happened? We are talking about the fractional part, 0.101, 1001. So what happened when we are going fractional part? That time what happened? We are going left to right. So 101 it is okay, 100 it is okay, but when it is 1, only 1 bit is remaining. So what happened? To construct a 3-bit sequence, we add 2 zeros in the trailing or in the LSB. So it is 100 means what? It is 4, 100 it is 4, and 10 it is 5. Again, if we are using both fractional and integer part, that time what happened? See here, 0, 1, 0. The first one is we are considering the integer part 0, 1, 0. So what happened? Only 0 is required because this one is 1, 0 to make a 3-bit sequence. So 0, 1, 0 is required. So it is 2, 1, 1, 0. It is 6, 1, 1. 111 is 7, and 100 is 4. 2 zeros are required in the LSB side. Okay. So here A leading 0, only 1 0 in the MSB, and 2 zeros are required in the MSB. Just a minute. Phone join ke aage. Raj Basfor? Raj Basfor? Are you hearing me?
Yes, sir.
See, just someone is joining right now. Okay. So you just inform all the students after 9, 10, I'm not allowing you. Suppose my class is 10 a.m. and someone is joining after 10, 10, then I'm not allowing you. This is the last and the final warning. Okay.
Okay.
Because otherwise what happen? I am discontinuing that particular one. So it is not a right time because 9:26 and someone is interested to join. So this is the first time, so I'm allowing him. But next time I'm not allowing. Okay. So any doubt about this one?
No, sir.
No, sir.
Any doubt?
No, sir.
Sir, then yes, you can ask one by one. Otherwise, it is conflicting. Voice is not I am recognizing. Yes, only one person can ask at a time. Okay, ask me. Any doubt?
Example 3, sir.
Huh?
Example 3, sir.
Example 3. Okay.
Yes, sir.
So now what happened? You आपको ठीक से दिखाई दे रहा है ना? Because example 3 before 101 one particular point is there. Okay. So this is the fractional part. Again, someone is joining. Tamalika Roy. Okay, PPT is visible to you? PPT is visible?
Yes, sir.
Yes, sir.
So someone is asking about the example 3. See here is the fractional part. Because before the numbers we are using before the binary numbers we are using some one particular point. So automatically you can understand this is the fractional part. So what when we are talking about the fractional part, that time see here, point number 2, the first sub point is scan the binary numbers from left to right. So left to right we are going from left. We are reading three bits. 101 it is okay. 100 it is okay, but only 1 is remaining left. Okay, that means now what happened? This particular one we are making to 3 bits. Okay, this is the rule when we are converting binary to octal. So what happened? How many bits are required to construct the 3-bit sequence? 2 bits are required, and we cannot use 0. No, sorry, we cannot use 1. Okay, we are using 2 zeros to make the 3-bit sequence. Okay, so 100 we are adding 2 zeros. So 100. So 100 representing as a 4. Okay, in decimal numbers. Or sorry, it is called octal numbers. Octal somehow it is octal and decimal are same. Are getting my point? Any doubt? So the answer is 0.544. And base 8 means what? It is we are converting from binary to octal. Any other doubt? Okay. Then I am going to the octal to binary conversion. So again, what happened? This the octal to binary conversion means what? Translate every octal digit into its 3-bit binary equivalent. So suppose it is very easy when we are constructing. See here example 1735 is the octal number because base is 8, and we are interested to convert the binary numbers. So what happen? We can see 1. 1 means what? We are making the 3 bits. Again, someone is joining. Just a minute. Manthan Das. So see here, 1 means what? We are making the 3 bit 001, 7 is 111, 3 is 011, and 5 is 101. So same thing, for example, because here we are using 37.264. So it is the, in this particular octal number, the integer part also present and the fractional part also present. So 3 means what? 011, 7 means 111, point 2 means 010, 6 is 110, and 4 is 100. Same thing 3.74, so 011. So this is very easy. Okay. Now what when we are converting to the decimal to octal conversion, the similar rule we are using when we are converting to the decimal to binary conversion. But the difference is that we are only dividing the base of 8, because what when we are converting to the octal numbers. So octal base is 8 or radix is 8. So we are using the division. Division means what? Until when we are the remainders is less than the divider numbers. Okay. So what happen here? If we are using this way, at that time what happen? We are dividing 3762 divided by 8, 472. So when we are multiplying 470 with 8, that means 2 is minimum to make a 3762. So remainder is 2. And again 470 we are dividing 58, it is 6 or something like that. It is very easy. So what happen here? Here the answer is 3762, decimal number answer is 726. Again, what happens when we are fractional part, when we are converting the fractional part to the binary octal conversion, that time what happens? Same rules we are using, but instead of multiply with 2, we are using 8. Okay, so 2.84. Again, what happened? The fractional part we are considering 0.848 into multiply. That time it is coming 6784 again 8. So what happened? This way it is going on up to what? Up to same number is repeating. When the some particular same number is repeating, that time we can stop there. So what happened? 0.356 we are converting to the octal, and answer is 0.265. Okay. Here any doubt?
It's how long should we continue?
So
like multiplying 8 to the numbers.
Yeah. So what happens? Sometimes what happens? Again, some particular suppose I'm using second particular part. Okay. So it is result is coming 6.784. So when we are multiplying again 0.784 after a few times, that time what happens? Some particular numbers are repeating. Fractional numbers are repeating. Okay. Suppose what happens? Some after dot again it is coming 2.848, but 0.848 already you can multiply earlier. So that time you can automatically know we can stop there.
Sir, is it always true that it will repeat in between, or it might not repeat and continue going on?
Yes, obviously, because see here, the number whatever whole the number is changing. Okay, but what happen? We are not considering the integer part. Suppose what happen? 2.848. Okay, but this particular whole the numbers are coming in the defined way. But we are considering only the fractional part. Maybe fractional part is repeated. Suppose when we are comparing with 2.84, but after that what happen? Suppose I am taking one assume. Suppose we are assuming 6.848. 6.784 it is not coming. Obviously 6.848 is greater than the 2.848. But what happened? How we can distinguish these particular two numbers based on the integer part? But here what happened? We are only considering the fractional part. When we are multiplying the left hand side, the equal of the left hand side, that time what happened? We are considering only the fractional part. So what happened? Some particular time what happened? That number is repeating. Are you getting my point?
Okay, so yes.
So what happened here? So only, but remember, this is the, one particular part I am forget to say. So when we are considering, suppose in this particular 3762 decimal numbers, what the result? the octal number result is 7262. But always remember we are considering only reverse order. So I am using the bottom to top this particular arrow. Okay. But in this particular fractional part, we are going the sequence wise. That means we are as the number is generated, that way we are considering only the fractional part. So here we are. So here suppose red color we are using 2, the second one is 6 and second one is 5. So 0.265 is the octal conversion of 0.356 of decimal number. Okay. So when we are, I have already discussed, when we are considering the fractional part, we are going the systematic sequence. But when we are going to the integer part, we are considering only the reverse. Okay, reverse. Okay. Now we are going to the hexadecimal number. The same, this is the another binary, this is the another numbering system. So what happened? It is the similar to the octal or any other numbering system, but here we are not using in octal number, we are using the 3 bits here. Okay. But here we are using the 4 binary digits are represented by a hexadecimal. So what happened? What is the range? Obviously, when it is 4 to the power 4 means what? 2 to the power 4 means 16. So what happened? We are making 4 bits of 2. So what is the range? Minimum value is 0 and maximum value is 15. And when we are adding all the hexa numbers, that total size is 16. 0 to what? 0 to 15. Are you getting my point? But
Yes, sir.
when we remember, when we are considering the hexadecimal number after 9, we are considering A, B, C, D, E, F. We are not using 10, 11, 12, 13, 14, 15. Okay. So now again ask me, so why we are using A after 10? Why we are not using 10? Why we are using A? Because what happened, this way, because A also what happened, see here some particular ASCII character, that time what happened, we are converting to the binary numbers. It is correct. For competition purpose, so what happened, minimize the complexity. So we are, instead of 10, we are using A, instead of 11, we are using B, something like that. Okay. So it is called a hexadecimal. So hexadecimal means what? It is hexa means what? It is the combination of numbering and alphabet. Okay. So it is very easy. See here, 0, hexadecimal 0 is binary is 0. All the bits, binary bits, see here, 4 bits group. All the bits are, sequence of bits are 4. So 0, 0, 0, 0, 0, 0, 0, 1, 0, it is representing 2, 3 is representing 0, 0, 1, 1, and A is representing 1, 0, 1, 0. When we are converting 1, 0, 1, 0 to the decimal number, you are getting 10. When we are converting 1, 0, 1, 1 to the decimal number, then it is 11. But when we are considering the hexadecimal, 1, 0, 1, 1 is representing B. B is the hexadecimal value. And what is the binary value? Binary value is 1, 0, 1, 1. So something like that, F we are denoting as a 1, 1, 1. So F is a hexadecimal number, and when we are converting binary, it is 1, 1. Okay. So again, similar, binary to the hexadecimal conversion. For integer part, we are using the scan. This particular part is same. Instead of 3 bits, we are using the 4 bits. You can see, scan the binary numbers from right to left, translate each group 4 bits into the, instead of 3 bits in octal number, here we are using 4 bits into the corresponding hexadecimal digit. And same concept we are using add leading. Leading means what? MSB zeros if necessary. And for fractional part, obviously we are going from left to right. We are scanning the binary numbers from left to right. And what happened? If 0 is required, then we are adding the 0 in the LSB. Okay. So some particular examples are there. You can check the examples. And if any doubt, then please ask me. Always I am not discussing. So some particular cases also you can say something. Okay. मैं ऐसा नहीं है कि मैं 2 घंटा क्लास ले रहा हूँ, मैं 2 घंटा ही मतलब I am continuing. Okay. Now you can carefully see the examples. If any doubt, then I am sitting here and you can ask me. Is it okay? Or any doubt? Please don't hesitate. Don't hesitate. बाकी लोग ऐसा है कि चुपचाप बैठ रहे हैं. एक लड़का yes sir, बाकी लड़का कहाँ गया? क्या हो रहा है?
Yes, sir.
Yes,
All
sir.
the students are present or not?
Yes,
Yes,
sir.
sir. Yes, sir. Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
I'm kindly request you, please keep your copy and pen with you, and also you can keep your textbook. What about the textbook? Maurice, when you are followed, then please maintain the textbook with your table. Okay. It is not like that. It is not like that. It is not like that. That means I'm going. If I continuing these particular things. Okay. So if you are facing any problem, then you can ask me, and also you can write all those things in the copy. Also, I'm taking time. Okay.
Sir,
I'm giving. Yeah.
sir, in fourth example, two trailing zeros are added or a one trailing zero are added.
Which one? Which particular example?
Fourth,
Example 4. Just a minute. Yes. See here. See here. I'm talking about the example 4. If you see here, I'm explaining this one. So what happened? 101. This is the given binary number. Binary number कुछ भी दे सकता है. It is maybe 1 bit, maybe 2 bit, maybe 3 bit. Okay. Suppose this is the given binary number, and someone is asking you convert this binary number to the hexadecimal number. Okay. So what happened here in example 4C here? Here integer part also available and fractional part also available. So which one is the integer part? 101. But remember one thing, when we are 101, only one particular sequence is there. Okay. But this particular sequence is only 3-bit sequence, not a 4-bit. So what we are using, we are adding the zeros in the MSB, left hand side. So 0, 1, 0, 1. So what is the meaning? It is 5. Are you getting my point? Are you
Yes,
getting
sir.
my point? Okay.
Yes, sir.
So after that, what happens? 0, 1, 0, 1. Again, it is 5 because it is already constructed with the 4-bit sequence. But remember, 111 is not a 4-bit sequence, and this particular sequence is appeared in the fractional part. So what happens? We are adding 0 in the LSB, not a MSB. So 11110 means what? 11110 means 0, 1, 2, 3,
14.
12, 12, 12, 13, 14. So 14 we are representing as a
E.
E in hexadecimal. Yes. See here, 11110 is E. Okay. So what happens when we are making the 4-bit sequence? This particular 11 is changes to 11110, and 1110 it is representing capital letter E. So here I am writing here clearly. I am writing a leading 0 and 2 trailing zeros are added. Okay.
Yes, sir.
Okay. Okay. Now what happens? See here, hexadecimal to binary conversion. So again, what happens? Translate every hexadecimal digit into 4 bits binary equivalent. So obviously, what happens? 3 we can representing 0011. A we can representing 1010, and 5 we are representing 0101.
Sir,
Yes.
sir, can we go to previous slide, please?
Yes.
Sir, in the last example, you have written leading zero and 2 trailing zero. Sir, it will be 1 trailing zero, na?
Yes,
110 equal to E.
Oh, yes. Yes, yes. Thank you. There is some typos error or grammatical error. I'm making is one. It's good. Now it is okay. So
Yes, sir. Thank you.
Yes, sir.
leading 0 and the trailing zeros. No need to write 1. Now it is okay.
Yes, sir.
Okay. If something is mistake from my side, then please point at me. Okay. It is good. A leading 0 and trailing zeros are added. Yes. So this one is C again. 3, 5, 3, we are representing 0011, A, we are representing 1010. Just you can check and ask me if any doubt. Because just you remember, the hexadecimal base or radix is 16 and octal radix is 8. Other parts are similar. Okay, binary radix is 2, decimal radix is 10. Based on that particular concept, we are doing this. See here, the last one, when we are converting 0.675, someone is asking the previous slide, when we are stopping this particular one. See here, 10.08. Now what happens when we are multiplying, because here is after point, here we are using, after decimal point, we are using 3 numbers. So 10.800, it is better, I am not writing here, but you can consider only 3. Don't go to the 4 and this one, 800, or the meaning is same, 800, or you are using 8 5 zeros or 2 zeros or 1 zeros. So here I am using 0.800 into 16, again we are getting 12.8. So remember one thing, 10.8, 12.8 are not similar. But if we are considering only the fractional part, 0.8 appears first and 0.8 appears second is same. So again we are multiplying this one. When this type of, again see 12 point, the last one again what happened, 0.800 into 16, again it is coming 12.8. So when we are multiplying 0.800, again same thing is repeating. That time what happened, we are stopped. So 10 is representing A in hexadecimal, 12 is representing C, and 12 is representing C. So 0.675 of decimal number, when we are converting to the hexadecimal, we are getting 0.ACC. But remember one thing, according to the table, this one is all are capital letter. If you are using a small letter, then it is totally sense. Okay, so remember, in hexadecimal, we are using only the capital letter. But instead of A, you are writing A, small letter A and small, you see here in the many in the exam, some particular students are writing C, very small. So automatically I am understanding this is a small letter. So your marks will be gone. Okay, so this thing is very careful. So here any doubt?
No, sir.
No, sir.
No,
No, sir.
Now we are talking about the hexadecimal binary or octal to binary or decimal to hexadecimal, decimal to octal. So the different type of number, based on the different type of numbering system and based on the radix, we are these particular things we are doing. Okay, but logical concept is same. If you are considering all the numbering system and all the conversion, what is the general formula or what is the general concept? The general concept is this one. So decimal to radix are and vice versa. Vice versa means what? Radix are to decimal. So we have to follow this particular 3 points. So radix are, maybe it is octal, maybe it is binary, maybe it is hexadecimal. We have to follow this. Follow a principle similar to decimal binary and binary to decimal conversion. When we are converting octal to decimal, because suppose radix are, suppose we are assuming that radix are equal to octal. That time what happen? Instead of radix are to decimal, we are right now we are saying that octal to decimal. That time what happen? Multiply each digit by corresponding weight and add them up. So multiply means what? Suppose how we can use this one? So suppose I am using 267. Okay, 267. That time what happened? How, suppose just a minute. Just a minute. So this particular screen is coming.
Yes, sir.
The screen is coming or not?
Yes, sir.
Yes,
Yes,
yes.
It is very difficult because I am not exactly. I am not daily using this one. But suppose see here I am using suppose. I am using this one. Suppose what happened 2 7. Okay, 275. When we are converting to the decimal, can you tell me how we can convert this one?
So we're
275.
converting this to decimal or binary?
No. Suppose what happened? We are converting to the octal to the decimal. Suppose 275 is what? 275 is octal. Okay. 275 is octal. Now what happened? We are converting to the decimal. Then can you tell me how we can convert this one?
we divide by
2 multiply with 8 to the power 2, then 7 multiply with 8 to the power 1, and 5 multiply to the 8 to the power 0.
What is your name, Beta? What is your name?
The Sean 7.
Good, very good. Remember, yes, this particular concept is very easy, but problem is that you remember there are different type of conversions are possible. So just you go to the system. So I'm again and again telling your concept must be clear. So
189.
how we can maintain this one? How we can maintain this one? See here, 2 and 2. It is taking time, because I'm not practicing. I'm not using generally this one. 2 and what happened? 8 to the power. How many digits are there? Because this one is the weight is 2. Okay. Plus we are using 7 into 8
1.
1. Yes, correct. And after that what happened? 7. 5.
5 into
Just a minute. It is taking too much time. Yes, it is very boring. 5 into 8 to the power 0.
0.
So you can multiply all those things and adding that time what happened? You are getting the some particular value, and that particular value is converting into 10. Okay. Just a minute. This again I am going with this one.
189.
Just a minute. So PPT is coming?
No, sir.
no, sir.
No, sir.
Just a minute. Now it is coming.
Yes, sir.
Yes, sir.
Yes, sir.
So what happened? Radix
Yes,
R
yes.
to decimal, multiply each digit by corresponding weight and add them up. So if you are using octal to decimal, then it is okay. We are multiplying with 8. But when we are using the hexadecimal, that time what happened? We are multiplying with 16. And when we are using suppose binary to decimal, that time what happened? We are using 2, multiply of 2 to the power something like that. But when we are converting decimal to the radix R, that time what happened? For the integer part, repeatedly divide the number by R. So suppose what happened? Decimal to the octal, that time what happened? The decimal numbers were dividing by 8, 8, 8, and when the remainder is less than the divider, that time what happened? We can stop them. Okay. For fractional part also we are multiplying with the, remember, for integer part we are dividing, and for fractional part we are multiplying by R. R means what? It is the base or radix. Suppose if we are using 16, that time what happened? We are multiplying with some particular number with 16. Again, we are considering only the integer part. Okay, when we are writing the output, the value, that time what happened? Only we are considering the integer part, and we are going the systematic sequence. We are not going to the reverse order. Are you getting my point? So that way, what happened? We can use the general form when we are converting decimal to radix R and vice versa. Any doubt?
Decimal to
So we are going to the next slide for just a minute. I'm stopping here. The next slide. Now what happened? If it is coming, if it is visible.
yes, sir.
Yes, sir.
Yes, sir.
Yes. Now we
Yes,
are
sir.
now we are going to discuss different type of number representation. Okay. So one is called as signed and unsigned number representation. So why this particular concept is coming? Actually, see some particular when we are talking about numbering system, that time what happen always some particular numbers is follow some particular sign symbol. So how we can understand this is the positive number or this is the negative number? So actually generally we are using. So we are. It is not like that we are using only. Just a minute. Who is want to join right now? Just a minute. Just who is this? Topas Roy. Who is Topas Roy? I am denying. So what happened? So because see here, so this particular number system, numbering system is always generally. See here, this particular numbering system actually binary numbers we are using in the digital circuit. Are you getting my point? So what happened? So representing any particular number, there are some particular sign symbol we are using. That is called a positive symbol or that is called a negative symbol. Because in digital circuit also we are using the concept of sign or unsigned symbol. Okay, so you heard about some particular oh, right now it is 10 now. Someone is thinking that class will be started from 10. Okay, no problem. Just think. Okay, so what happened? Here we are using some particular sign and unsigned. Okay, before we are going to discuss about the sign and unsigned, you have to know some particular conventions which we are using the numbering system. Some conventions we have to follow. Okay. Again, someone is interested to join the password. So what happened? Bit actually when we are some particular terms we are using. Okay, that particular terms is what? Some conventions of binary number system. So when we are talking about the bit, what happened? Single binary digit. So bit represented as single binary digit. You already know what is binary digit. Binary digit is represented by 0 or 1. Okay. Now what happened when we are talking about the nibble, NIBBLE, nibble. So always remember it is the collection of 4 bits. So indirectly what happened? Collection of 4 bits means what? It is similar to the hexadecimal number. That means when we are converting hexadecimal number to the binary numbers. That time also we can make the 4 bits of group. But when we are talking about the byte, so byte means what? It is collection of 8 bits. So what is the collection of that particular binary sequence? Always size is 8 bits. So if we are forming the 8-bit size, that time what happened? It is called a byte. And the word it is not a fix. Actually, it is depend on how much what is the content exactly. Based on that particular content, it is maybe sometimes it is 16 bits, maybe sometimes it is 32 bits, maybe sometimes it is 64 bits. Okay, so it is depend upon that means what is the content of that particular word. Okay, so this is the general convention which we are using the binary number system. Now I'm asking one particular question, all of you. Here the answer is available, so just you, but you can conceptually you can just tell me one thing. Suppose n-bit binary numbers are there. Okay, how many distinct can be represented in n bits? Suppose I have a 3 bits. Suppose I am giving one example. I have a 3 bits. So how many sequences are possible in 3 bits? Can you tell me, anyone? Regular student, backlog student, anyone can tell me?
Sir, 8.
8.
Yes, it is correct. 8. Now,
It's
now,
8.
yes. Now you are telling 8. Yes, the answer is correct, because without knowing, without formulating anything, your answer is not coming. So can you tell me what is the logic? How you can get 8? Yes, 8 is correct, but how you can get 8?
Sir, every place can hold 2 digits, 0 and 1. So 2 into 2 into 2, sir, 8.
Yes. So basic concept is that why we are multiplying with 2, bhaiya? Why we are not multiplying with 3, 4, 5? Why we are only multiplying with 2?
So because binary numbers 0 and 1.
Yes.
Only 2 binary numbers.
Yes. Suppose the thing is something defined. You heard about the, yes, binary numbers is very common these days. Okay, people are know about. Can you heard ternary number? T-E-R-A-N-A-R-Y, ternary number. Ternary number is representing more than 2 bits. More than 2 bits. So that time what happened? This particular concept is failed, because this particular concept only we are using the binary numbers. Yes, that time what happened? We are using 2 power. That means what? Multiplying with 3. If we are using in ternary, if we are using 3, then we are multiplying with 3. If we are using 5, then multiply with 5. Okay, that way. But we are now, right now, we are talking about only binary numbers. Okay. So why we are using 2? Because binary numbers always produce only 0 and 1. So 0 and 1 means what? Only two directions are there. One is 0 and one is 1. Okay. So when we are combining the sequence of 0 and 1, that time what happen? Only two possibilities are there. So that's why it is 2 to the power n. Then why we are using n? Because n is representing the bits. If you are using 3 bits, that time what happen? 2 to the power 3 equal to 8. If you are using 4 bits, 2 to the power 4 equal to 16. If you are using 5 bits, 2 to the power 5 equal to 32. Okay, this is the basic concept. Till now we are not discussing about the signed and unsigned number. This particular concept you have to remember. Okay. Now we are going to the, at first we are going to the numbers can be either unsigned or signed. Obviously, because some particular numbers are positive numbers, some particular numbers are negative numbers. These particular numbers, how tackle by the digital circuit. Some competitions are required, some systematic rules are required to represent the unsigned and signed numbers. Are you getting my point? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So when we are talking about the unsigned number, has only a magnitude. There are no bit sign is there. Unsigned number means what? There is no signing. If we are not writing anything, that means obviously by default it is the positive. So when we are representing the unsigned number, that time what happen? We are considering only magnitude. We will discuss what is a magnitude and what is the sign. Okay. We are, for the time being, just you remember, we are using only magnitude. We are not using any particular sign. Okay. But the next point, see, when we are talking about the sign number, that means what? There's particular some sign is present. It is maybe plus, maybe minus. Okay, but plus we are not considering, sorry, minus. Specifically, it is minus. A sign number has both a magnitude and also a sign. So always remember, when we are talking about the unsigned, we are considering only magnitude, but no sign bits are there, or sign symbol is there. And when we are talking about the sign number, that time what happened? Magnitude as well as sign representation are there. Okay. So sign may be a positive or negative. Okay. So if you are using the sign number, that time what happened? Based on some particular sign bit, you have to know if this one is positive based on the sign bit. Also, you have to know that this one is the negative. That is called as sign. So now we are discussing details about the unsigned binary numbers. So n-bit binary numbers can have 2 to the power n distinct combinations. You have already know. So when we are talking about when we are talking about 2 to the power n distinct combination, what is the minimum value? Minimum value is 0 and maximum value is, because 0 is also we are considered. So 0 including with n. N is a number of bits. For that particular purpose, maximum number is formulated 2 to the power n minus 1. Remember, it is not a 2 to the power n minus 1, but we can read this way, 2 to the power n minus 1. Are you getting my point? Suppose we are considering 8 n equal to 8. Suppose we are assuming that n equal to, n equal to 3. That time what happened? Based on this one, how many distinct combinations are possible? 2 to the power 3 equal to 8. So here, see here, we are considering the minimum value is 000 and maximum value is 111. So here I am writing 0 to, what is the range? 0 to 2 to the power 3 minus 1. So 2 to the power 3 is 8 and minus 1 equal to 7. 7 means what? This particular 7 representing as a decimal. So how many numbers we are representing? From 0 to 7. But totally how many sequence are there? What is the size of this particular n equal to 3? Is 8.
8.
So here we are writing 8 distinct combinations are there. Someone is waiting to join. Just a minute. पप्पू कुमार गौतम, ये कौन है पप्पू कुमार? पप्पू कुमार गौतम, hello
Sir, yes sir,
your digital electronics, you have backlog or not?
yes sir. Yes sir.
Which
backlog.
particular which exam? Mid semester exam, internal exam or end semester exam?
Sir, overall back sir.
Okay. Okay, you can good. You can. It is very if you can regularly, if you are present, then your concept will be clear. Okay.
Okay sir. Okay.
So based on this particular concept, now I am constructing this particular table, or see here, n equal to, if you are defining n equal to 8, n equal to 16, n equal to 32, and n equal to 64, that time what is the range based on this particular general formula, 0 to 2 to the power n minus 1. So when we are considering 8, that time what happened? 0 to 2 to the power 8 minus 1, and it is representing, actually it is representing total number is 256, but here because we are going to 0 to 255, but why 255 is coming? Because 2 to the power 8 minus 1, so it is 255. But when we are using the 16, that time what happened? 0 to 2 to the power 16 minus 1, so 65, it is 65 comma 525. It is not a two defined binary and a decimal number. Remember, it is the same number. I'm just for divided 65,535. Okay, so 32, we are going 0 to 2 to the power 30, it is millions actually. 429496295, and when we are considering 64 and equal to 64, it is even bigger. Okay, so it is not possible to write here. So 0 to, you can calculate this one. It is maybe 21 digits, something like that. It is coming. Okay, so this is the range based on the n bits, and this is the unsigned number. Here we are using this particular 00, 001, 010. All are behaved like as a magnitude. There is no, we are not using any sign bit concept here. So this type of number is called a unsigned binary numbers. Any doubt?
No, sir.
No sir.
No, sir.
Very good.
Thanks.
Next one is, see here, unsigned binary numbers. Again, we are discussing continue. That means what? How we can representing the unsigned binary numbers. Yes, obviously we are discussing what is the unsigned binary numbers. It is okay, but how we represent, or we are going to represent the unsigned binary numbers. So obviously, based on our earlier discussion, when we are talking about the n-bit binary integers, that time what happened? We can write bn minus 1. We can, if we are reading from left to right, that time what happened? Bn minus 1, bn minus 2. Why we are using n minus 1? Because we are considering in the LSB b0. For that particular purpose, we are using 0 to, with the range is 0 to n minus 1. and this one is the fractional part. I'm sorry, integer part. I am not using any fractional part. So just we can read B0, B1, B2 up to Bn minus 1. So when we are, this is the n-bit binary integer, okay. But suppose we are considering that this one is the unsigned binary number. That time how we can represent in the decimal? The same thing we are using. The same concept when we are converting to the binary numbers to the decimal. Okay, Bn minus 1 to the power n minus 1 plus something like that, Bn minus 2 to the power n minus 2. And after that, last one is B0 to the power 0. Okay, if you are going from left to right, if you are mainly you can read as from right to left, B0 to the power 0 plus B1 to the power something like that. Now, third point, each digit position has a weight that is sum of power of 2. Okay. So suppose in this particular table, I am using only 4 bits. I am representing 4 bits. 4 bits. I am using 4 bits unsigned binary numbers. So what I can see here, from the decimal plus 0, plus 1, plus 2, plus 3, as usual. All are 0, 0, 0 is representing 4 combination because here n equal to 4, 0, 0, 0, 1 is 0, 0, 1, something like that. So after plus 15 is what? 1, 1, 1, because here n equal to 4. So the how many bits? The combination of bits is 4. Okay. So this one is the normal. Unsigned is nothing but a normal procedure, and we have to follow the normal procedure. Okay, this is called a unsigned. Are you getting or not? Are you getting or not?
Yes, sir.
अभी क्लास में होता तो मैं बोलता कि आप क्यों सो रहे हैं क्या, अभी तो आपका मर्जी है, आप क्या कर रहे हैं मुझे पता नहीं. Okay, so because you can on your video, but what happened again, bandwidth is very slow. Okay, so because I am using my personal network device, so it is very yes. So if it is video is all the video is on the time, what happened, bandwidth is very low. Okay. Next, what? Sign integer representation. Many of the I have already discussed many of the numerical data items that we are using signed. It is maybe positive or negative. Some particular cases, what happen? By default, if we are not representing any sign symbol, that time what happen? By default, we know that that particular number is positive number. But what happen in digital circuit? Some particular cases, what happen? We have to mention this one is the positive number and this one is the negative number. So for that particular purpose, sign integer representation is very essential. Okay. But remember one thing, there are different type of approaches we are using when we are representing the sign integer representation. The first one is called a sign magnitude representation. Second one is called a ones complement representation. And third one is called a twos complement representation. We are discussing one by one. Okay. Anyone can tell me what is the time right now?
10, 12 answer.
Okay. 10 times. Now see here, when we are considering the first approach, sign magnitude representation, that time what happened? Suppose we are considering n bit. We are assuming that n bit, we are going to n bit representation because this is the generalized form. So n bit, we are not considering any particular value, 8 bit or 3 bit. Suppose we are considering n bit representation. When we are using this particular approach means what? Sign magnitude representation. That time what happened? We are followed this particular two rules. Okay. The most significant bit, that is MSB, indicate the sign bit. Because always you remember, when we are representing the sign magnitude, that time what happened? Two particular parts are there. One is called a sign bit, one is called a magnitude. Okay. So what happened? Most significant indicate sign bit. Okay. Only we are considering only one bit, not a more than one bit. So what happened when it is a sign bit, when it is representing as a 0, then automatically we are understanding that is the positive. And when it is 1, that time what happened? It is negative. And because in MSB we are considering the only one bit, and how many bits are remaining? N minus 1 bits are remaining. So all the n minus 1 bits representing as a magnitude of the number. Okay. and whatever the value we are getting based on that particular value, maybe the range of the number is minus 2 to the power n minus 1 to plus 2 to the power n minus 1. You know already why I am using 2 to the power n minus 1 n minus 1. That particular part we have already discussed in the previous slide. Okay, so what happened here? It is graphically we are representing, see here, bn minus 1 representing as a sine wave, and b0 to bn minus 2 representing as a magnitude. Any doubt?
So the sine bit will be separate or together with the
No. We are writing in the same sequence. We are writing the not a separate means what it is. Logically, it is separate. Logically means what it is by place in a one particular place. You can combine with bn minus 1 with bn minus 2. It is not like it is sine bit and we are writing somewhere else. The representation is same. But you always remember when we are using the sign magnitude representation, always most significant bit we are considering as a sign bit. And when it is 1, that time it is negative, and when it is 0, that time it is positive. Okay?
So if it is 1 triple 0, then should I assume that it is 2 to the power 3 or minus 0?
That particular part I will come later. Okay. That particular just after a few slides you automatically know that means how it is.
Okay.
So what is the range? Range is minus 2 to the power, and that means range means what I am talking about including sign and magnitude. Okay. So this range is minus 2 to the power n minus 1 to plus 2 to the power n minus 1 minus 1. See here. But remember one thing, when we are talking about the sign integers, there have some particular problem. See here, to representing one particular, to define a representation, this particular 0 numbers. See here, plus 0 and minus 0, in mathematically it is same. It is no meaning. Yes or no?
Yes, sir.
Yes.
Because plus 2 and minus 2 is something different. Okay, no problem. But when we are considering plus 0 and minus 0 equal to 0. Okay. But what even for representing this one, two different type of sequence are required. So what when our memory size is large, our computation is, it is unnecessarily we are using more computation. Okay. So that is the one problem. Okay. But sometimes we can ignore this particular problem. Okay. So what happened plus 0? So see here the most significant bits and magnitude. I am writing here some particular difference. Some particular gaps are there. You see plus 0 colon. Here most significant bits I am writing separately. Okay, separately means I am in between 0 0 and 0. Here some particular gaps are there. Okay, you are getting or not?
Yes, sir.
So this particular MSB part 0, it is representing the positive number. So it is plus 0. And minus 0, so MSB is 1 and all other remaining n minus 1 bits is 0. So it is 1 means what? According to the sign integer representation, the sign bit, if sign bit is 1, then this particular number is minus. So it is minus 0. Are you getting? Now someone is asking me few seconds or few minutes ago. So this particular table is representing this. See here. So when we are considering the here have some particular problem. Here I am using here unsigned. This one is called a signed number. Okay. So see all the positive numbers, the first most significant bits is 0 0 0 0 0. So plus 7 0 triple 1, that means what? The first MSB it is considering as a sign bit. So 0, it is 0 is appeared, so it is plus 7. So plus 6 means what? It is 0 is appeared, so 0 1 1 0. The same thing if you are representing in the sign numbers -7, that time see here, the first most significant bit is, don't use the first, most significant bit is 1. So I am using here red color. So this one is 1, remaining n-1 bit means what? 111 is representing 7. So -6, see here, most significant bit is 1, so it is minus, and 110 is representing 6. The most significant bit is 1, and 101 is representing as a 5. So it is most significant bit is 1, so it is -5. So this way we are representing. Any doubt?
Yes, sir.
No, yes, someone is asking.
Yes,
Yes.
sir. So
Yes, tell me.
if the binary numbers are given, how do you identify if they're signed or unsigned? Like if suppose 1100 is given, then should we think it's just
no. Your concept is something different. So what happened? At first you assume that if you are using sign magnitude approach, that time what happened? You are assuming that I'm using sign magnitude approach. Normally what happened? Without any binary numbers, we cannot directly convert to the sign integers or unsigned or sign integers. Okay. At first what happened? Someone is telling you, or what happened? Suppose you are constructing that particular sign numbers. That time you assume that yes, I'm using sign magnitude approach. If you are using the sign magnitude approach, that time also you can consider MSB is the sign bit, not for general purpose.
Okay, sir.
Okay, if you are using that particular approach, then you can just consider that yes, my MSB is the sign bit.
Okay, sir.
Are you getting my point?
Yes.
So any doubt for other student?
No, sir.
No, sir, it's clear.
No, sir.
So there are three possible approaches. One is called a sign magnitude representation. Second one is called a ones complement representation, and third one is called a twos complement representation. Okay. Now sign magnitude representation already we are discussing. Okay. If any doubt, then again we'll discuss in the next class. You can ask me what is the problem. So we'll discuss. Now directly we are going to the ones complement representation. So ones complement representation. What is the basic idea? Basic idea is that if the number is positive, it is exactly same in the sign magnitude form. Okay. But remember, we are not using the sign magnitude. We are using the, which particular approach we are using? We are using the ones complement. Sometimes this one is writing this way also. Okay. Positive numbers are represented exactly as in sign magnitude form. This is the first idea. The second idea is that negative numbers are represented in ones complement form. Okay. Now, how we can compute the ones complement form? So just very simple, ones complement form, when we are computing the ones complement of a particular number, that time it is very simple. Just you can remember, complement every bit of the number. Okay, if we are complementing the number 1 to 0 or 0 to 1, that time what happens? This one is called a first complement. Most significant bit will indicate the sign of the number. So same, 0 is positive and 1 is negative. So that this particular part is similar to the sign magnitude. Okay. Suppose how I can suppose here, just a minute. So suppose if we are considering the 4 bits, that time what happen? How we are representing the 5? 0,
1,
1, 0,
1.
1. And the same thing if we are representing,
1, 1.
okay, so this is the, we are interested to complement the first, we are using the first complement with -5. So 5 is representing 0, 1, 0, 1. Okay, it is no problem. Now, what is the rule of the first complement? We are making
1.
0 to 1 or 1 to 0. So for that particular purpose, we are just using the, we are completing the first complement. 1, 0, 1, 0, 1, 0. See the difference between two numbers. So what happened? The first MSB, if we are considering the only the 5, that time what happened? 0, 1, 0, 1. So first MSB is 0. So this one is the positive number. And when we are applying the ones complement, that time what happened? See here, most significant bit is 1. So what happened? This is the -5. Are you getting my point?
Yes, sir.
Yes, sir.
So all the students are very silent. Why? All the students are yes. Okay, no problem. Just but remember, you can just attend the class. Okay, don't feel sleepy and all those things. Okay. So this is the concept. So what happened? Here we are using. So here, how many bits we are using? Suppose we are constructing this particular complement n equal to 4. We can use the 8 or 12 bits. It is no problem. Okay, just we are adding the 0 as beside. Okay.
So,
Yes.
so if we were to represent 8 or 9 or above, in which the MSD is 1, then we'll go to 8-bit formation.
Sorry, I'm not getting. Again, please ask me.
So suppose if we were to represent 8, that would be 1, 0, 0, 0. So will that be, so should, like taking one's complement, will it become 0, 1, 1, 1, or should we make another one in the 8-bit side?
No, see here. Now it is 8. Okay. If you are representing 8, then no needs to do the ones complement. Why you are using the ones complement? Because it is the positive numbers. So it is the unsigned numbers. So as it
Sorry,
is
-8.
-8.
So yeah,
yes.
from 8 to -8, yeah.
So that time what happened? Yes, if you are using the -8, sorry, just a minute. Just I am saying this one. Just I am showing. So -8. Okay, very good. So for a particular purpose, what happened? You want to apply the ones complement with -8. So
Yes,
at first, what happened? Just a minute. Okay. See here. Now what happened? 8, and so if you are applying the ones complement with -8, that time what happened? What is at first what you will do? Just you can write the 8. Okay, and after that it is converting to the simply binary sequence. Okay, and now what happened? Now you are minimum how many numbers are now? How many bits are required? Minimum bits are required to construct the 8. So obviously 4 bits.
4.
Okay, but according to the question are demanding that you can use the 12 bits. Then how you can represent it? So what happened? Adding 4 bits you can add in the MSB side, because this is the not a fractional part. Yes or no? This is the integer part. Okay. So what happened? Suppose I am using 4 bits. Suppose here I am using the 4 bits 1, 0, 0, and 0. Okay.
Yes.
Now what happened? Here what happened? 1, 0, 0. When we are converting to the -8, that time what happened? It is converting to the 0, 1,
1, 1,
1, 1. Okay. This way we are representing.
No, sir, but the first number, the MSD here is 0 instead of 1 in -8.
Oh, yes. Yes. Now you can tell me then. So no. Yes, this one is the. So I am asking this particular concept. Why it is so? I know this one is 1 and this one is 0.
So can
Now,
we take another 4 bits? Another 4 bits were left, making it 8-bit thing, or?
So what happens? See here. So 8 is what? the minimum is the, how many bits are required to represent the 8? Here it is
4
required
bits.
4 bits. Okay, so 4 bits we cannot directly apply to the edge complement. Some other bits we have to require. Are you getting my point?
Yes,
So
yes.
maintain the sign bit. So that particular part I have already discussed in the table. You can check that one. So you can easily, just a minute. Just a minute. Stop sharing. And directly I am going to the Google Meet. Okay. See here, in this particular table I have already mentioned, when we are using the 4 bit, what is the range?
Till 7. Till 7.
0
Minus
till 7. So till 7. So what happened when we are applying the 8, that time what happened? We cannot representing because we are going to the more than and 4.
Okay,
Okay.
sir. Okay, sir. Understand.
So it is the range actually, it is the fixed range. Otherwise what happened? We are violating our rules.
Yes, yes.
Otherwise we are violating our rules. See here, if we are using +2, that time what happened? We are, because n equal to 4, so we are writing here 0, 0, 1, 0. Now see here, where is the -2? -2 is just 1's complement of +2. So 0, 0, 1, 0 is +2 and 1, 1, 0, 1 is the -2. So first one is what? Most significant bit, so we are representing as a -2. Now same thing is see +7. +7 is we are representing as a 0, 1, 1. But when we are representing the 1's complement, that time what happened? It is we are doing the all zeros goes to 1 and 1 we are changing to 0. So it is 1, 0, 0. And most significant bit is 1, so it is -7. It is clear, but see here you can see the PPT. Then you can see here I'm in the right hand side I'm writing -4. 1's complement of 0, 1, 0, 0 is 1, 0, 0. Okay. So what happened? You just maintain the bits actually because 7 is itself is a 4 bits. The minimum number of 4 bits are required. Sorry, 8. Number 8 minimum 4 bits are required. So we cannot apply this one. More bits are required to represent. See here. So always you remember this one. Yes, whatever you are asking, just you can maintain this particular one. The range of the numbers that can be represented to 1's complement. Always you can, if you know this particular range, then your problem will be solved. Whatever you are asking. So whatever maximum is always to the power n minus 1 minus 1, and minimum always minus to the power n minus 1 minus 1. Are you getting my point? But again, what happens? The same problem occurs like a sign magnitude in 1's complement. Again, what happens? See here, if we are representing +0 in this way, that time what happens? How we can represent the -0? Because we are introduced the 1's complement, because we are computing the 1's complement. So every 0 changes to 1. So 1, 1, 1. So for 0 numbers, it is problematic. So it is problem is occurred because what happens? Two distinct values are represented the same number. So here +0 -0 it is same, meaning is same. But here what happened? For this particular 2, we are getting the 2 different binary numbers, the sequence of binary numbers. Okay. Now, what is the advantage of the 1's complement representation? So this particular part we'll discuss later, because when we are designing the circuit and all those things, then you can automatically understand what is the benefit the 1's complement. The one particular great benefit of 1's complement is that subtraction can be done using addition. We are not separately designing for subtraction. Okay, addition means what? We are adding two numbers, but same concept we are applying for subtraction. Okay, and that particular part easily handled by the 1's complement. So extra circuit is not required. That means extra function is not required for subtraction. Function is nothing but we are converting to the circuit with the help of gates or flip-flops and whatever. Okay, but see here, if we are using the 1's complement, the addition concept we are using for subtraction. That is the one benefit. That means one circuit competition is less. Okay. And obviously, when the circuit is the component of the circuit is very less, that time what happen? We are leads to substantial saving in the circuit. That means power dissipation is very less. the circuit size is very less, the complexity of the circuit is very less. Okay, that is the benefit of one's complement representation. And how we are getting the advantage, that particular part we'll discuss after few lectures. Okay, so when we are designing the subtractor and when we are designing the adder, how we can using the concept of one's complement. Okay. Now see here, till now in this particular lecture we are discussing, apart from the binary and decimal numbers, we are discussing the hexadecimal numbers, octal numbers and their representation and their conversion. Okay, and general formula how we are converting one particular numbering system to the other numbering system. Apart from that, what happens, some particular numbers always require the sign bit. Okay, so what happens, maybe we are writing some particular function, that particular function, the sign magnitude is required. So how we can represent the sign magnitude? There are three approaches. One is called a sign magnitude, one is called a ones complement, and another is called a twos complement. But always you remember what is the relation between the ones and twos complement. So without ones complement, you cannot go for twos complement. So ones complement is a necessary part of twos complement, or you can say that ones complement is a necessary competition of twos complement. Okay, twos complement also for representing the sign also we are using the twos complement. Okay, and apart from the ones and twos complement, also we are know that what is the sign magnitude form. So sign magnitude form is what? One particular, the first MSB bit, the most significant bit we are considering as a sign bit, and remaining other bits, that means n-1 bits we are called a magnitude. If 0, then it is positive, and 1 it is negative. Okay. That's all, because we are going step by step. So one particular lecture I am not covering all those things. Otherwise, whatever you can cover. Now, what is your main target? What is your main task? Now you know all the conversion procedure. So you can open your Maurice Meno book or whatever that normal textbook, whatever I have provided already, and you can solve problem, or you also you can do the unsolved problem. Okay. So if any doubt, then please write down that particular problem. In the next class, you just tell me, and I will clear your doubt. Okay, and also you can carefully check how we are representing the sign and unsigned number. Okay, just a minute. All of you, are you hearing me?
Yes, sir.
Yes, yes, sir.
Yes, sir.
Now tell me what is the answer if we are using sign magnitude from of class 51. Tell me the answer. You are taking so much time. What is the problem? Are you hearing me?
Yes, sir.
So 11000111.
Huh?
Sorry, 110011.
110011.
110011.
Wrong.
001100.
marks you are getting. So whatever I am discussing, only
Oh,
these particular things you
0001.
can understand.
So 0001
The answer is 0,
0011.
0011 triple 1001.
0, 0, 1,
1.
and 1.
Yes,
So
sir.
this particular bit is called a sign bit. A sign bit. Okay. Sign bit. And remaining all the 110011 is called a magnitude. Okay. Can you tell me this one? Minus 51. What is the binary sequence if we are using the ones complement?
1001100.
Sir, 1001100.
Yes, sir.
Yes.
1001111.
1001111. The answer is there. The answer is there. 1 0 0. So it is 1 0 1 1 00. Are you getting?
Yes, sir.
Minus 51.
Yes,
what is the answer?
Yes, sir.
Answer is 1 0 0 1 1 00.
00.
Yes, sir.
Now just you can tell me this one. If I am writing 2 5 2598 point, this one is point 675. And this one is what? This one is decimal number. Now you convert to hexadecimal number. Just please do this one. 2598.675. This is the decimal number. How you can convert to the hexadecimal number? You can tell me the result. Just clearly tell me. What is the result?
A26.80.
The answer is A
A2C.S. 26.acc.
A2
6.
A2
6.
6
Dot ACC.
A. Very good. Yes. So how many C you are using? Only 2 CC's copy. No, yes, sufficient.
Yes, sir.
6 7 8.
Yes, sir. Yes, sir.
If you are using a 3C also, then it is no problem. Your answer must be correct. Okay.
2C, sir.
But is 3C also no problem, but you can write 2C. 2C it is okay.
2C is okay.
Now you convert this one. One. Just do it. What is the answer? Hmm?
65.53.
Pardon?
65.53.
Yes, anyone can tell me any other answer?
65.53.
65.53. Or anyone can tell the different answer?
65.52.
The correct answer is
65.52.
yes, correct.
65.530.
65 point
530.
52.
65 point 65 point. Remember this particular number also very important. The answer is 52. Not a 53, not a 543, not a 52. 65.52 is the correct answer. You can carefully check. 1011
Yes, 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 yes.
0011. So just this one is the binary number. Now just convert to the hexadecimal number and tell me what is the result. One zero double one zero double one zero double one.
Two dB.
Pardon?
2 dB.
2 dB. Is it correct? 2 dB.
Sir, 2 dB.
No.
Yes, sir, correct, sir.
This one is correct.
2 dB.
Yes, sir.
Yes, sir,
2
2
dB.
dB, 2 dB, sir. Yes, sir, 2 dB.
2 dB.
Yes, good. 2 dB is the correct answer.
Sir. Correct.
Correct answer. 2 dB is the correct answer. So this way you can continue and you can check all the questions are available in the textbook. So some particular problems is the some particular problems are unsolved and some particular problems are solved problem. So you can practice all the problems, and if you are getting any doubt, then we will clear your doubt in the next class. Okay.
Yes, sir.
Sure.
Thank you very much. So
Thank
now,
you, sir. Thank you, sir.
so most probably Saturday, I will inform you. Most probably some particular extra class I will conduct on Saturday because now Saturday you are also free. So if I will take the class, then I will inform you. No problem. Okay.
Okay, sir. Thank you, sir.
Because